The Open Systems Interconnection protocols are a family of information exchange standards developed jointly by the ISO and the ITUT. The standardization process began in 1977. While the 7-layer OSI model is often used as a reference for teaching and documentation, the protocols originally conceived for the model did not gain popularity, and only X400, X500, and ISIS have achieved lasting impact. The goal of an open standard protocol suite instead has been met by the Internet Protocol Suite, maintained by the Internet Engineering Task Force. Overview: the OSI protocol stack is structured into 7 conceptual layers. The layers form a hierarchy of functionality starting with the physical hardware components to the user interfaces at the software application level. Each layer receives information from the layer above, processes it and passes it down to the next layer. Each layer adds encapsulation information to the incoming information before it is passed to the lower layer. Headers generally include address of source and destination, error control information, protocol identification and protocol parameters such as flow control options and sequence numbers. Layer 1, physical layer. This layer deals with the physical plugs and sockets and electrical specification of signals only. This is the medium over which the digital signals are transmitted. It can be twisted pair, coaxial cable, optical fiber, wireless, or other transmission media. Layer 2, data link layer. The data link layer packages raw bits from the physical layer into frames. It is specified in ITUT Rec. X212, ISO IEC 8886, ITUT Rec. X222 and others. This layer is responsible for transferring frames from one host to another. It might perform error checking. This layer further consists of 2 sublayers, MAC and LLC. Layer 3, network layer, connectionless network service ITUT Rec. X213, ISO IEC 8348. SCCP is based on X213. Connectionless Network Protocol ITUT Rec. X233, ISO IEC 8473-1. Connection-Oriented Network Service ITUT Rec. X213, ISO IEC 8348. Connection-Oriented Network Protocol ITUT Rec. X233, ISO IEC 8878. This is the use of the X25 protocol to provide the comms. Network Fast Byte Protocol ISO IEC 14700, End System to Intermediate System Routing Exchange Protocol, ISO IEC 9452. Intermediate System to Intermediate System Intradomain Routing Protocol, ISO IEC 10589, later adapted for the TCP/IP model. End System Routing Information Exchange Protocol for use with ISO IEC 8878 ITUT Rec. X116, ISO IEC 10030. This level is in charge of transferring data between systems in a network, using network layer addresses of machines to keep track of destinations and sources. This layer uses routers and switches to manage its traffic, so here it takes all routing decisions. It deals with end-to-end data transmission. Layer 4, Transport Layer. The connection mode and connectionless mode transport services are specified by ITUT Rec. X214, ISO IEC 8072. The protocol that provides the connection mode service is specified by ITUT Rec. X224, ISO IEC 8073. And the protocol that provides the connectionless mode service is specified by ITUT Rec. X234, ISO IEC 8602. Transport Protocol Class 0, Transport Protocol Class 1, Transport Protocol Class 2, Transport Protocol Class 3, Transport Protocol Class 4, Transport Fast Byte Protocol ISO 14699. The transport layer transfers data between source and destination processes. Generally, 2 connection modes are recognized: connection-oriented or connectionless. Connection-oriented service establishes a dedicated virtual circuit and offers various grades of guaranteed delivery, ensuring that data received is identical to data transmitted. Connectionless mode provides only best effort service without the built-in ability to correct errors, which includes complete loss of data without notifying the data source of the failure. No logical connection, and no persistent state of the transaction exists between the endpoints, lending the connectionless mode low overhead and potentially better real-time performance for timing-critical applications such as voice and video transmissions. Layer 5, Session Layer, Session Service ITUT Rec. X215, ISO IEC 8326, Connection-Oriented Session Protocol ITUT Rec. X225, ISO IEC 8327-1, Connectionless Session Protocol ITUT Rec. X235, ISO IEC 9548-1, the session layer controls the dialogues between computers. It establishes, manages and terminates the connections between the local and remote application. It provides for full duplex, and half duplex or simplex operation, and establishes checkpointing, adjournment, termination, and restart procedures. The OSI model made this layer responsible for graceful close-of sessions, which is a property of the Transmission Control Protocol, and also for session checkpointing and recovery, which is not usually used in the Internet Protocol suite. The session layer is commonly implemented explicitly in application environments that use remote procedure calls. Layer 6, Presentation Layer, Presentation Service ITUT Rec. X216, ISO IEC 8822, Connection-Oriented Presentation Protocol ITUT Rec. X226, ISO IEC 8823-1, Connectionless Presentation Protocol ITUT Rec. X236, ISO IEC 9576-1, this layer defines and decrypts data types from the application layer. Protocols such as MIDI, MPEG, and GIF are presentation layer formats shared by different applications. Layer 7, Application Layer. Common Application Service Elements Association Control Service Element ITUT Rec. X217, ISO IEC 8649, ITUT Rec. X227, ISO IEC 8650-1, ITUT Rec. X237, ISO IEC 10035-1. Reliable Transfer Service Element ITUT Rec. X218, ISO IEC 9066-1, ITUT Rec. X228, ISO IEC 9066-2. Remote Operations Service Element ITUT Rec. X219, ISO IEC 9072-1, ITUT Rec. X229, ISO IEC 9072-2. TCAP is related to X219. Commitment, Concurrency, and Recovery Service Element, Security Exchange Service Element, this keeps track of how each application talks to another application. Destination and source addresses are linked to specific applications. Application processes Common Management Information Protocol ISO 9596/X700, Directory Services X500, later modified for the TCP/IP stack as LDAP, File Transfer, Access, and Management, Message Handling System X400, Virtual Terminal Protocol, ISO 9040/9041, Remote Database Access, Distributed Transaction Processing, Interbury Loan Application Protocol, Document Transfer and Manipulation, Document Printing Application, Document Filing and Retrieval. Routing Protocols, Intermediate System to Intermediate System ISO 10589, End System to Intermediate System ISO 9542, Interdomain Routing Protocol ISO 10747. See also, Internet Protocol Suite, OSI Model, Protocol Stack, TCP/IP Model, WAP Protocol Suite, X25 Protocol Suite. References FTAM support claimed by IBM, Novell, Sun, Unisys etc., Joint Interoperability Test Command.